Hello friends, coming to the second method of replacement theory, when the things are gradually deteriorating, but for us the present value of money is also important. So in such cases we will be making use of PV factor. Now what is PV factor? It is the present value factor and the operating cost will be multiplied with such factor. Now how to calculate this PV factor? Generally the PV factor is given at the end of your books in the form of tables. You will be just looking the values from that table, or the second method is you can calculate the PV values as well with the formula 1 divided by 1 plus r raised to power n, where r is the PV range and n is the number of years. So how to go about with the questions when PV value is given or discount rate is given? Let us learn with the help of one practical question. Now in this practical question you have been given the data for 7 years and maintenance cost is being given from 400 to 2100. Now besides that, in this question it is given that the cost of the machine is rupees 5000, that is incurred in the beginning of the machine was purchased, and the scrap value S has been given to be 0. It is not given. So depreciation will be C minus S, so there is no S. So this cost will be leading to the depreciation only. Another important point is in this question is you have been given the discount rate also. So discount rate, it means the money value has been considered. So this has been given to be 9%. So this is the point where replacement of the equipment has to be done, which is deteriorating over here, but the money value is also changing. That is why this discount factor has been given. So the procedure is more or less similar. The minor changes will be there. So we will be calculating again the average cost only, but instead of average cost we will name it as weighted average cost because we have been given the discount rate also. So first of all, now we have to make a column for the discount rate and we will name it to be PV value, present value PV, and here the discount rate is 9%, so we will be seeing the values at the rate of 9%. For the first year, if the maintenance cost has been incurred in the beginning of the year, so in the first year PV value is always considered to be 1 for every percentage, whether it is 9, 10, 11. In the first year it is taken to be as 1 only when the maintenance cost is incurred in the beginning of the year. If nothing has been given in the question, you can assume that the maintenance cost has been incurred in the beginning of the year. So in the first year we considered this value to be 1. For the second year you can look at the tables given at the back of your book and there the PV values have been given. For under the 9% you will be finding some values which will be 0.917. It will be different for every percentage. Under the 9% you will be seeing these values, and just remind that do not see the annuity tables or cumulative values. You have to see the simple values. 0.841, 0.772, 0.708, 0.650 and 0.596. So these are the values that you will see at the back of your table. Otherwise, to calculate these values, the formula that has been given, it is 1 divided by 1 plus r raised to power n. So you can use this formula as well to calculate these values, where r is the PV factor, that is 9%, and n is the number of year for which you are calculating the value. For example, you have to calculate for the second year, so you can put the value 1 divided by r is 0.099%, n is the number of years for the second year, so you will be getting 0.917 only. Otherwise you can take it from the tables. If I want to calculate for the third year, I will be doing 1 divided by 1 plus 0.09 whole power 3, so I will be getting 0.841, this value. So like this we have to just write down the PV values. Now for the third column, what we have to do is we have to calculate the present value of maintenance cost. You have to multiply the second column and the third column. You have to multiply the PV values with the maintenance cost. So 400 into 1, it will be 400. 500 into 0.917, it will be 458.5. 700 into 0.841, it will be near about 588.7. Next, 1000 multiply by 0.772, it will be 772. 1300 into 0.708, 920.4, you can write that. 1700 into 0.650, 1105, and 2100 into 0.596, 1251.6. So this you have to do, multiply present value with the maintenance cost. Next, the steps will be same. Now we will be calculating the cumulative present value of the maintenance cost. You have to cumulate this column as we have done in the previous question. So first value will be same, 400. Second, it will be 858.5. Add 588 into it. It will be 1447. Add 772 into it. 2219. Adding 920. 3139. Adding 1105. 4244. And the last will be 549 and 6. The next will be the calculation of depreciation, that is C minus S. In this question only C was there, S was not there. So it will be same, and the cost given was 5,000. So it will be same for each year. If the salvage value would have been given, this would have been different for every year. Now once we calculate the depreciation, the next step is to calculate the total cost. And how we have calculated the total cost? Sigma MT plus depreciation. Adding these two columns, we will be getting the total cost. So it will be 5,000 plus 400, 50, 400, 5858 near about, 6447, 7219, 8139, 9244 and 10496. This will be the total cost. After this, now in the previous method we have divided it with the number of years, but here we will not divide it with the number of years, we will divide it with the PV factor, that will be cumulative. So you have to now calculate cumulative PV factor value. How you will calculate it? Cumulate this column, the third column. First value was 1, write it 1, add 0.917 into it, it will be 1.917. So make it a cumulative frequency. Now add 0.841 into it, it will be 2.75 and 8. Add 0.772 into it, it will be 3.530. Adding 0.708 into it, 4.238. Adding 0.650 into it, 4.888, and the last will be 5.484. Now finally we will be calculating the average cost, and you will name here it to be weighted average cost. What you have to do is total cost divided by cumulative PV factor. 5400 divided by 1. So first value will be 5400. 5858 divided by 1.917. It comes out to be approximately 3056. 6447 divided by 2.758. It comes out to be 2338. Next will be 2045. Next will be 1921. Next will be 1891, and the last will be 1914. Now you have to see where the cost is minimum. Now the cost is reducing. See, here the cost is minimum in this year. That is my second last year, 6th year, the cost is minimum. So conclusion will be same. You will be writing that weighted average cost of 6th year is less than the 7th year. So replacement period is 6th year. You have to replace the asset in the 6th year only. So this is how you will be calculating the replacement years when the monetary value has been given in the form of PV factor. One important point here is taking the PV factor as 1. If the maintenance cost is considered to be in the beginning of the year, take it 1. Otherwise, you will start it from here only, 0.917, 0.841, like that. So this assumption you have to give in the equation if nothing has been given.